Let's talk about what it means to be a geometric sequence. A geometric sequence is generated by multiplication. We repeatedly multiply by the same value. So to determine if these example sequences are geometric or not, we need to think about what it is we're doing to find the next term, and if that thing we're doing is multiplying by the same number over and over, it will be geometric. That value we multiply by is called the common ratio, and we will use r to represent it. In example 1, it's 1, 2, 6, 24, 120. Well, at first we're multiplying by 2, then by 3, then by 4, then by 5. So we are not multiplying by a constant value, so no, this is not a geometric sequence. In the second example, I'm multiplying by 1/3, by 1/3, by 1/3, by 1/3. So yes, this is geometric. The common ratio equals 1/3. In number 3, I'd be multiplying by -2, again by -2 here, and again by -2 here. So yes, this is geometric. The common ratio is -2. Key concept. The rule for a geometric sequence. The nth term of a geometric sequence with first term a sub 1 and common ratio r is given by a sub n equals a sub 1 times your common ratio to the n minus first power. The n is now in the exponent because repeated multiplication is done through exponents. An exponent means take the base and repeatedly multiply by it. We have to have the n minus 1 because we didn't work backward and find the 0 term. We're using the first term. The n minus 1 will account for that balance and back up the exponent by 1 for every n value we plug in. In the example from the textbook, the nth term of a geometric sequence with a first term of 3 and a common ratio of 2 is given by a sub n equals 3 times 2 to the n minus first power. So with geometric sequences, once we plug in the first term and the common ratio, there isn't any simplifying we can do. That's our rule. So in example 4, it says to write a rule for the nth term of the sequence -8, -12, -18, -27. So if this is a geometric sequence, to find its common ratio, I need to take my second term and divide it by my first term. Well, this doesn't divide evenly, so I'll make it reduce to its most simplified form. The negatives divide out because a negative divided by a negative is a positive. Both 12 and 8 are divisible by 4. So in its most simplified form, I get 3/2. Let me see if it's the same for the next two terms. If I take -18 and divide by -12, again a negative divided by a negative is a positive. This time they're both divisible by 6, so if I divide by 6, I get 3/2. If I check the final two, -27 divided by -18. Negative divided by a negative is a positive. They're both divisible by 9. If I divide by 9, I get 3/2. So I know that my common ratio is 3/2, and I know that a sub 1 is -8. So then my rule, a sub n will equal -8 times my common ratio, 3/2, to the n minus first power. That's the rule for the nth term of the sequence. They also asked me to find a sub 8. So if I replace n with 8, I have -8 times 3/2 to the 8 minus 1, or -8 times 3/2 to the 7th. Well, that's -8 times, if we do 2 to the 7th power, we get 128. 3 to the 7th power is 2,187. I can reduce the -8 and the 128. They're both divisible by 8, so I can reduce it to become -1 times 2,187 over 16. So that a sub 8 will equal 2,187 negative over 16. If you wanted to make that a decimal, comes out to be -136.7 approximately. Number 5 says to write the rule for the nth term of the sequence 5, 2, 0.8, 0.32, and so on. So to find your common ratio, divide these two. R will equal 2 divided by 5, or 0.4 as a decimal. And we can see that here. If you take 0.8 times 0.4, you'll get 0.32. So then your rule, a sub n, is equal to that first term, 5, times the common ratio, 2/5 to the n minus 1 power. To find a sub 8, replace the n with 8, so we have 5 times 2/5 to the 8 minus 1, so 5 times 2/5 to the 7th. Well, 2 to the 7th we just did in the last problem, that's 128. I'm going to leave the bottom as 5 to the 7th so that I can see how I can reduce these. I can divide out one of the 5s and make it 128 over 5 to the 6th power, which would be 128 over 15,625. So again, that's 15,625 for the denominator. So that is what a sub 8 would be. 128 divided by 15,625. Number 6 says one term of a geometric sequence is a sub 3 equals 5. The common ratio is 2. Write a rule for the nth term of this sequence and then graph the sequence. So if we start writing our rule, we would do a sub 1, which I don't know yet, times the common ratio to the n minus first power. To find a sub 1, I need to use this fact, that the output is 5 when the n value is 3. So I now solve this equation for a sub 1. I simplify my exponent so that it's 2 squared. So that's 4 times a sub 1, which tells me that a sub 1 must have been 5/4. Therefore my rule, a sub n, will equal 5/4 times 2 to the n minus 1 power. To graph it, I'm going to create a little table. Remember, the x value is your n, your term number, 1, 2, 3, 4, 5, etc. And we will never connect the dots because there's nothing in between. There's the first term, there's the second term, there's the third term, but there's no term 2.6 or anything in between the whole values. And a sub n, our actual terms in the sequence, are the outputs, the y values. So if n is 1, I'd have 2 to the 0, which is 1, times 5/4 gives me 5/4. If n is 2, I would have 2, take away 1 is 1, 2 to the first is 2. 2 times this would be 10 over 4, because you only take a whole number times the numerator, not both the numerator and denominator. So 2 times 5 gives us 10 over the 4, but 10 over 4 would reduce to 5/2. We already know that when n is 3, the output is 5, and that's because 3 minus 1 is 2, 2 squared is 4, 4 times 5 is 20, but divide out the 4 and you're back to your 5. if we plug in 4, I'd have 2 cubed, which is 8. 8 times 5 is 40, but divided by 4 gives us 10. If you plug in 5, 5 minus 1 is 4. 2 to the 4th power is 16. The 16 and the divide by 4 would reduce down to 4 times the 5 gives you 20. So here are the points I'm going to plot. At 1, we're at 5/4, which, since they're counting by tens, is virtually on the x-axis. And the next one, 5/2, is 2.5, ever so slightly higher. The next one is 5, so it'd be halfway. And then we're finally at the 10. And then we're at 20. We're doubling every time, so we know the next one would be at 40. And then we'd be at 80. So we'd be up off the chart. Remember, we don't connect the dots because it's a sequence and there just aren't any values in between. What if we have to find the rule for a geometric sequence and we're not told the first term or the common ratio? Let's take a look at how we could figure this out. So what we do know is that the output is 45 when the n value is 3. Therefore, 45 must equal the first term times your common ratio squared. We also know that 405 equals your first term times the common ratio to the 5 minus 1 power. So 405 equals the product of your first term and your common ratio to the 4th power. To solve this system, I'm going to need to use some substitution. So I'm going to solve this first equation for a sub 1. I'm going to divide both sides by the r squared so that a sub 1 equals 45 divided by r squared. Now I'm only allowed to do this assuming r squared is not 0 because I can't divide by 0. But I know that r squared can't be 0 because I've got terms that aren't 0 beyond the third term. So now I'm going to take this and substitute it in place of a sub 1 over here. So that 405 will equal 45 divided by r squared times r to the 4th. Well, this, r to the 4th divided by r squared, is really just r squared. So now I can divide both sides by 45 and see that r squared must equal 9. So therefore r must be 3. Now that I know what r is, I'll plug it in over here to find a sub 1. So I take 45 divided by 3 squared, or 45 divided by 9, and I see that a sub 1 is 5. And therefore, my final rule, a sub n, is 5 times 3 to the n minus 1. Okay, so what do we do if we want to turn it into a geometric series rather than a sequence? So what happens if we want to add up all of the terms in that sequence? The sum of the first n terms of a geometric series with common ratio r not equal to 1 is S sub n, the sum of the first n number of terms, equals your first term, a sub 1, times 1 minus the common ratio to the nth power, divided by 1 minus the common ratio. Let's look at an example. If we have this geometric series where we're simply multiplying by 5, first of all we need the rule. So the rule, first term is 1, common ratio is 5, so it's 1 times 5 to the n minus first power, just so that we can see the rule and we know all the pieces. Then the sum of the first 10 terms, s sub 10, would equal that first term, which is 1, times 1 minus the common ratio of 5 to the 10th power, divided by 1 minus 5. So I recommend that you simplify the denominator. 1 times anything is just that thing, so the 1 out front can be dropped. Your denominator becomes negative 4, and then I would type this into your calculator exactly how you see it there. 1 minus 5 to the 10th power, put some parentheses around that numerator, and then divide it by negative 4. You should then get the correct sum, 2,441,406. Take a second, pause this video, and try that calculation in your calculator. Make sure that you really are able to correctly type that and get 2,441,406. The next example is given to us in summation notation. They want us to find the sum of this geometric series, the first 6 terms. So the sum of the first 6 terms is equal to the first term. Well, if I plug in 1 for I get 4 times 3 halves to the 0 power. Well, anything to the 0 power is 1, so this is really 4 times 1, or 4. So 4 times 1 minus the common ratio, which is the 3 halves, to the nth power, which in this case is 6, divided by 1 minus 3 halves. So we have 4 times, the denominator will be negative 1/2. In the numerator, we have 1 minus, we have to figure out what 3 to the 6th power is. So 3 to the 6th power is 729. 2 to the 6th power is 64. So you get 4 times, if you simplify the numerator, it's negative 665 over 64 divided by negative 1/2. But we never divide by a fraction, we multiply by a reciprocal instead. So it's really 4 times the negative 665 over 64 times negative 2. Well, the 4 times the negative 2 would be negative 8 times that fraction. Negative times a negative is a positive, and these can reduce. Divide them both by 8, so I'll get 665 over 8. That's my final sum. Problem 10. In 1990, the total box office revenue at U.S. movie theaters was about $5.02 billion. From 1990 to 2003, the total box office revenue increased by about 5.9% per year. Write a rule for the total box office revenue, A sub n, in billions of dollars in terms of the year. Let n equal 1 represent the year 1990. Okay, so in 1990 we had 5.02 billion, so that's A sub 1. Since they said let 1990 be year 1. This is going to help us get our common ratio. If we want to increase by 5.9%, that means our multiplier should be 1.059, because you want to keep 100%, which as a decimal is 1.00. Add on 5.9%, which as a decimal is 0.059, so that gets you your multiplier 1.059. To the n minus first power. Anytime you want to increase by a percent, you should always have 1 and then the percent here, so that you keep all of what you have and add on this percent. You're always adding here if you're increasing. If they wanted you to decrease by 5.9% per year, change this to be a subtraction sign. So what was the total box office revenue at U.S. movie theaters from 1990 to 2003? Well, that is a 14-year time period if you count each year, 1990, 1991, 1992, etc. Or you can subtract them and add 1. So to find S sub 14, so the sum of those 14 years, we take the first term, 5.02, and multiply by 1 minus the common ratio, which is the 1.059, to the 14th power, over 1 minus 1.059. So you can type that all into a calculator. Just be careful to put the numerator all in its own parentheses and the denominator in its own set of parentheses. When you type that in, you should get approximately 104.76, but remember that's in terms of billions, so it's about $105 billion in revenue. Okay, so those are the notes on geometric sequences. Take a look at your textbook if you'd like some more information or to read in more detail and see some other examples. Then you should begin on the homework assignment. Good luck.